What's going on, guys? We got another project going on here. So what we got going, got a customer that brought these little augers to us, and they've got a well that has a bunch of dirt and rust and stuff packed down in it, and so they need to auger that crap out of there. So they're going to use these. They need me to weld some adapter fittings on there so that they can get it down into the well to get the crap out. So they brought these fittings, and what we're going to have to do, so we're going to take this nipple, we're going to cut it in half. We're going to take half of it, we're going to slide it down here with the thread side up, and we've got to have it centered so that it doesn't wobble. So we're probably going to do a little bit of machining for this. We're going to slide it down. I'll end up welding it to the shaft, probably top and bottom. That way they'll be able to hook some pipe to this, and that's what they'll use to get it down into the well to run this auger and hopefully get the crap out. And then we've got this other adapter fitting. We're going to cut this little keyed end. I don't know if you can see that, but it's actually keyed. It's got a hex head on it so that you can hook a drill chuck to it. So we got to cut that off. This is going to be an adapter. We're going to take the end of this, we're going to cut that off. I'm going to turn an adapter piece in the lathe and slide it in here, and I'll weld that adapter piece into here so that he can connect his drill chuck to that, and then that will be able to adapt to the pipe. So he'll be able to use his drill for these augers. We got to cut this nipple in half. We're going to use half of it on this one, half of it on this one. So that's what we've got to do tonight. So we're going to start by going over and cutting the nipple in half, and then we'll start taking measurements on the pieces we need to turn in the lathe, and we'll go from there. Alright, so I think I've come up with a plan on what I want to do for a design for these adapters. It's going to look like this. So this piece here will slide down the inside of the pipe, and then the pipe will actually sit like this, and I'll weld here, here, and then the shaft for the chuck will come here, and I'll weld here and here. I think that's going to be the strongest, and I think it's going to work best for what we got to do. So that's the plan. So we're just trying to get all our measurements together. Okay, I think we got it. Well, let's go over to the lathe, see if we can't get this started. Okay, so we did find a chunk of 1.5 inches hot rolled. It's going to be perfect for what we're using it for. We're going to go ahead and face this off. The parts are only going to be about a 1/2 inch thick. We'll turn it down to our greatest OD and we'll go from there. Alright, so we got our piece all machined. You can see there's some burrs on there. I'm going to have to knock that one off, but I'm waiting for my stinking tooling to show up in the mail. So as soon as my countersink bits show up, I'll be able to clean that up and chamfer all these sharp corners. But I figure instead of swapping all the tooling out and everything, I'll go ahead and machine the other 3 of these, and then we'll clean them up and make them pretty at the end. I'm also going to put a little bit of a chamfer on this inside corner for a weld, because it's going to weld like that. So I'll chamfer the pipe, I'll chamfer the fitting, and then we have a couple holes we got to drill on either side of this for lubrication while he's drilling. So 1 down, 3 to go. Alright guys, so we just wanted to announce who the 1,000 subscriber winner was for the drawing. We just used one of the random comment pickers online. So the winner of the drawing was Don Sheedle 3. So Don, we're going to be getting a hold of you so we can send you your prize. And once again, we just want to tell everybody we appreciate the support. There will be more drawings coming up. We're going to try to get better at this, and let's get back to the video. Alright, so we're on our last bushing here. We're just taking it at 40 thousandths per pass. It's going a lot quicker now that we've got the center hole drilled and the OD machined. So then we can just get our shoulder machined in there. Should be right on the money. Oh, that was a little tight. We're gonna take another 5 thou off that one. That should put us right on the money. There we go. I like it. Okay, so now all that's left to do is part that one off. When you guys part something off, it's always good to slow down your lathe. I'll give you another pointer. If your DRO quits working like mine has on the Y travel, you can always use your dial indicator. I'll just snap it on the metal here, and then you swing it up here. So you want to put your dial right there up against the carriage, and then you can go ahead and zero it. So if I zero it, okay, now I'm going to count. So I'm going to go 250. Okay, so it's 250 thou. We're right on the money now. Okay, we've slowed our lathe down. Then you want to use a lot of cutting oil. The first little bit it gives me these big chips, but see, then it smooths right out, and then it just gives you a nice consistent chip. I can feed it fairly fast. If you look how fast I'm feeding it with my hand. See, I can feed it pretty fast, so it doesn't take too long to part it off. coming up on our final cut here. Okay. There's our 4 pieces. So we've just got some burrs to knock off those, but we got to wait for our tooling tomorrow. So that's probably all we're going to do for those tonight. And then once we get the tooling, we'll go ahead, put them back in the lathe, and then we can start getting the nipples cleaned up and ready to TIG weld these on. So that's probably all we're going to do for tonight. See you guys tomorrow. Alright, I want to give you guys an update. So got back out here tonight, wanted to work on these. Tooling didn't show up, but the more I looked at the design, there was a couple things I didn't like. So the original design, I machined them all like this. If I take that shoulder and I put it in the pipe like this on this end, that's going to interfere with the threads, and that was something I didn't think about. So I ended up taking one of those pieces, machining the shoulder off, and slid it down in the pipe. And I'm actually going to push that in just a little bit like that and weld it on the inside so that it doesn't bleed over and destroy the threads on the end of this. That way I'll be able to put a nice pretty weld on the inside there, and it's not going to affect anything out here. This end, I beveled the pipe. I did bevel the inside corner there, and I chamfered the outside corner just for looks. You can see I got a nice weld joint there. So I'm going to weld it on the outside here. We'll slide the rod up through. We'll put a weld here, and obviously in the center here. The last thing we'll have to do is we will have to put this in the milling machine and drill a couple holes, because he's got to have lubrication through this. So I'm going to get the outside welds done first, put it in the mill, drill a couple holes on either side so that fluid can get through. Then I'll run the bit down through the center hole, weld these center holes up, and that'll be it. So I think right now what I want to do is I want to do these outside welds first, get those knocked out, see how this one goes. I'm going to buff the zinc off, because that's always fun to deal with. So I'll go ahead and buff that off, and then we'll see if we can't get this one welded up. Got the inside all cleaned up, got the outside all cleaned up. We're ready to weld that up. We're using 16th inch mild TIG rod. Okay, so we got that one all welded out. Okay, I'm going to see if I can't get this tacked up. Well, there's obviously still some zinc on this one. Well, this zinc is really fun to play with. I apparently didn't get it all. Well, every time it pops, it's like it sucks it right onto the tungsten. And then you gotta sharpen your tungsten again. I thought I cleaned it good enough, but I guess I didn't. Alright guys, I'm not gonna lie, that is a tough one. So I got that inside all welded out. It's not real pretty, but it is welded out. That freaking zinc was really messing with me. You can see there's a couple spots where it bled through and messed up the threads. That was one of them. So I build it back up. I'm gonna run a pipe die over the top of it, cut the threads back, and it should be fine. But yeah, that top weld sucks. I am gonna go over and see if I can't get these machined and prepped up to do the other one. So we'll go to that point. Alright, we're going to get this one tacked up. I'd like to try to get both of these welded out tonight so they can cool, and then I can worry about doctoring up threads and all that stuff tomorrow. I'm going to try to stick this one down in the pipe further, so that it's not out here where the wall is so thin. I think that's going to help not blow through, so we're going to try that with this one. It is going to be more difficult to weld, but I think it's worth it. And I almost forgot to buff the zinc off. Okay, I'm just going to try, well, I'm going to focus on two things. I'm going to really try to center my heat towards the inside, towards the plug, and I'm also going to try to keep my heat down with my foot pedal and just kind of wash it up into the side. Hopefully that'll work. Okay, so that one went a lot better. I probably should have pushed that other plug down deeper on that other one. I didn't have anywhere bleed through on the threads. Oh, there is one teeny little spot right there, but that's not a big deal. It'll still thread on and off. We're gonna go ahead and let both of these cool. All that's left is we gotta drill holes in them, and I don't want to do that while it's hot. So once they cool, we'll drill some holes in them for lubrication, and then we'll slide them up on the drill bits and weld them out, and then we'll go from there. Alright guys, so here's the next step. Okay, so we got our nipple in the chuck on the pipe threader here. You see there's a couple spots on here that I had to repair, so I'm hoping that I can just match the threads up with my dies and go around a couple times and hopefully not jack anything up, but hopefully we can cut the threads back into it so that the customer can thread it on. Okay, so I think we're matched up there. I'm just really hoping this doesn't screw anything up, so we're gonna try it and see. Okay, I think that's gonna work. You can see it did cut the threads back in. I'll clean it up with a file, but I think that's gonna work. But let's go clean this one up with a file and check it with a fitting, and then we'll go from there. I'm going to run this through the pipe threader one more time just because it's sticking up just a little bit. So I'm going to tighten the dies down just a little bit and then run it through one more time, and we should be good. Okay, that feels better. We'll check it again. Okay. So you can see here, this is where our repair had to be made. You can see where it is, but it's pretty good. I feel pretty good about that, considering the situation. I mean, it's not ideal, but it's gonna work. So the next thing we got to do is we got to drill some holes in it for some lubrication. So we will clean it up a little bit. We're going to take it over to the mill and drill some holes. They don't have to be in any sort of special spot. So we're just going to do 2 holes on either side of the center hole. And we got to do it top and bottom so the fluid can get all the way through. We're going to figure that out right now, and then we'll go over to the mill and drill them. We're using a 3/16 drill bit here because we don't have a whole lot of room to work with here. So we're going to drill a couple holes on either side of the center hole. You got to remember, we're going to have to weld that in too, so it's getting kind of crowded down in there. So we're going to drill these 2 holes, see how that looks. Okay, so you can see we got 4 holes there where the lube can go through. We're going to do the same thing on this end because it's got to be able to go clear through. So 4 more holes. Okay, so we should be good there. That one's ready to weld on the bit, and then that'll finish that one up. So since we're drilling holes, I'm going to drill the holes in the other one. Okay, I just wanted something to knock the paint off. Those little Scotch-Brite attachments are awesome for that. If you don't want to get real aggressive, you just want to take the paint off or smooth something up, they're perfect for that. So we're ready to tack this. Bridger said we should do a hair reveal. So he thinks that should be the prize for the giveaway, is the hair reveal. So whoever wins the giveaway gets to see my hair. Okay. So that's why Bridger's not in charge of the giveaway. I'm sure you'll all agree.
Why did you say that? I was kidding.
You should know you can't say something like that to me and me not. Okay, so we're ready to tack this up. I just want to show you guys what my plan is here. If you look right here at the top of the piece of pipe, I've recessed that shaft down in there about maybe 3/16 of an inch. And so I'm just going to fill that up with weld and do a plug weld there. That way I don't interfere with these lube holes. So I'll just fill this up and it'll be nice and flush, and then I don't think it's going anywhere. I'm pretty sure if anything's going to fail on this, on these ones, it's probably, if it's going to fail, I think it's going to shear the rod off. And I'm not saying I think it's going to fail. I'm just saying I think the way we've built it, if it is going to fail, it's going to fail right there where the shaft meets the pipe. When I'm building something, I try to think about, okay, where's the weak point? Where do I need to beef it up? Where do I need to strengthen it? Where do I need to add some sort of bracing or make it stronger? All right, enough talking. I'm going to get this welded out. Woo! As you can see, the cutting fluid on the pipe threader makes really nice smoke. Okay, so we got our plug weld all filled up. Now we're gonna flip it. We're gonna weld this end. Now this one's gonna be a little trickier. So you can see how tight the corner is there. So I'm gonna keep my tungsten really sharp, and I'm gonna use 1/16 inch rod, and I'm just gonna try to keep that fillet nice and tight up against the rod there so that I don't bleed out into those lube holes. So we got that all welded out. One down. Hopefully that's going to work good for him. So what he's going to do is he's going to use the pipe. He'll throw a coupling on this, and then he'll use the 1-inch pipe to run this down through the well and drill out all the rust and dirt and crap in there. And then when he needs to blow water down in there to stir it up, he'll hook a garden hose to it, and that's what the holes are for, is they're going to shoot water down there, so he'll be able to rinse it out. So hopefully it works for him. So that's the first one. We're going to do the same process, only we're going to do it with the little one here. So I'm just going to do the exact same thing. I'm going to clean the paint off of this, put it in there, and start welding it out. So 2 down, we got our little adapter to build. And that was going to be pretty easy because all we have to do is take a piece of round stock. We've got just a piece of 1-inch hot rolled that we're going to have Bridger machine, and we're going to be able to drop it down in our little adapter for the drill. Will slide down in the center hole and then it will get welded out. So we're going to have Bridger machine the part and then I'll weld it out. And all this is for is it's just the adapter so that he can connect stick after stick after stick until he gets all the crap out of there. This will mount to the adapter. He'll put a great big drill on it and he'll just drive this down through there and see if he can dig all the crap out of there. So we'll go back over to the lathe and Bridger's going to turn apart for us. You got your safeties on. You don't ever machine with gloves on, because for those of you guys who don't know that, when you do machine work, you don't ever want to machine with gloves on. And they say you shouldn't machine with long sleeves. We're just going to be really careful. We don't ever reach over the chuck to get stuff back here while it's running. I don't know if you guys have noticed, but usually once I get done machining, I'll pop it out of gear. So even if it does start, the chuck's not going to spin. You just got to be smart. You got to respect the tool you're working with. If you disrespect it, that's when you get hurt. We've all done it, but you know, obviously with bigger tools like this, sometimes you don't get second chances, so you always want to be careful. This is how you run your carriage in and out. This is your cross feed. This handle controls your feed, so in and out, left and right. And you can change that depending on which way you engage this. Usually the first thing you do is you face it off. You know what that means? It's where you cut the face, right? Okay. So we're going to check, see what gear we're in. Okay, that's a good speed. So now run this over. Get your hand out of your pockets. Okay, now drive this in a little. Okay. Now when you get close, you want to go slow, because you don't want to bang that into it or it'll break the insert. Okay, so now you want to touch off. It's called touch off, so go in a little. Now go in this way. Okay, a little more. Okay, so now you know when you go in it's going to touch. So now you want to slowly go that way until it touches. Okay, so you're touching, that's touched off, right? Okay, so now we're going to zero. We'll actually come out here. We'll zero. Okay, so now you're zero. So now you'll just come over. Okay, so now it's going to cut. So now you want to push this in and push it down. Push it in, push it down. See how this one's running? So if you push it in and go down, it's going to feed your cross feed. Okay, see how it's not cutting anymore? So now disengage it. Pop that handle up. Right there. Okay, that's good. That's disengaged. Now back it out. Yep. Okay, stop. Now you're going to go over just a little bit more. Now you're going to engage it again. No. Okay, good. Now we want to cut our OD. Okay? 910 thousandths.
It's time for today's super cool tool.
Alright guys, so for today's super cool tool, we're going to be talking calipers. Calipers have been an important part for this project and many other projects that we've worked on here in the shop. So if you don't know what calipers are, they are an instrumentation tool. A lot of people mistakenly call these micrometers. This is not a micrometer. These are calipers. And this is just a 6-inch set of calipers. And you can get sets from 6-inch clear up to, I used to run a set that was 36 inches because I was machining a lot of really big rollers. So you can get them anywhere from 6-inch to, I'm sure they probably make some that are even bigger than 36-inch, but that's the biggest I've seen. There's two different types of calipers. There's digital and analog. Personally, I prefer analog. and it's for no other reason other than it's just my preference. So I like to physically see the needle work, and I guess I just have a little bit more confidence in watching the needle, and I feel like I have a better chance of knowing if something's going to be wrong with the instrument. If I pull up a measurement and it doesn't seem right, and then I go to zero it, I can physically see the needle go back to zero. That's one of the reasons that I prefer analog. There are some very nice digital calipers out there. I've used some very nice digital calipers. I just prefer the analog version. Some scenarios where you might want to use calipers is when you're measuring like shaft size, or when you're measuring the internal bore of something, and I'll give you guys some examples of that. Okay, so here are a couple of examples on what you would use calipers for. So if I want to measure the internal bore of this, I could use them to give me that measurement. So there's jaws on both sides of the head. This top side, these jaws are used for measuring the ID. So if I'm going to measure the ID or the bore of a piece of pipe, I would use those jaws. And so I'll slide them in there, and I usually wiggle them back and forth, and then you can see these ones here are 1.635. If you're going to measure the OD, and I've got a piece of stainless round stock here, so if I want to know how large that is on an OD, I use the larger jaws. And then same thing, I like to kind of twist it, rock it back and forth so that I'm sure that I'm right on the money. And this is 1.625. So those are just some scenarios where you would use a set of calipers. So these calipers here, they're nothing fancy, but I have actually had them for quite a while, and they have done me a very good job. The brand is OEM, and I believe I ordered those. I believe I ordered them off Zorro Tools. They're not a super well-known brand, but I think OEM tools are made in Taiwan. I've looked on the case and on the calipers, and I can't find anywhere where it says where they were made. So if you're looking at getting a set of calipers, some of the higher quality brands that you should look into are Starrett, Brown & Sharp, Mitutoyo. Those are some of the more popular and some of the more quality brands. Just a few habits that you would want to make when you're using calipers. So you always want to zero before you measure. So on these, I'll always zero them first, and I make sure that I'm right on zero. So you can see that I'm right on, and I'll usually bump it a couple times just to make sure. The other thing I do is I'll wipe the inside of the jaws with my fingers, because sometimes you might get some metal shavings or something on the inside of there, and that throws it off, and that can throw off your measurement. So you always want to make sure that your zero's good before you measure. And then I like to make sure that the gears spin freely. There's a small gear in here, and that's how it spins the needle. So you want to make sure you keep that clean and oiled up. If I was in the market to buy a set of calipers, I would make sure that I got one with the case. I try to keep them in the case and the case closed as much as possible, just because in a fab shop where you got welding and machining going on, grinder grit is really hard on things. And so if you leave this open and somebody's grinding and they throw grinder grit on your instruments, chances are it's going to get down in those gears and it's going to bind them up, or it's going to wear them out, and then it's not going to measure properly. The other thing you want to look at is what the backlash is. And when I say backlash, I mean, so if you run the dial one direction and then you go to run it back the other, you want to make sure that it moves and there's no slop, there's no backlash. So there's no slop in between directions, if that makes sense. So as I go back and forth, it's tight. There's no slop. So I know that it's giving me an accurate measurement. There's actually a couple features with calipers that a lot of people don't realize. One of those being, if I want to know how deep that center drill hole is, just as an example, I can actually use this tool to measure it. And there's a lot of people that don't realize that. But the end of this tool, see how it sticks out like that? The end of this tool can actually be used as a depth measurement tool as well. And so if I take this piece of stock and I set this in here, and I run this down till it bottoms out, and then I'll usually rock it back and forth, and I make sure that my instrument is flat up against the face, so that hole is 0.337 deep, 337 thousandths deep. Okay, something else I think we should go over is how to read a set of calipers. So if you're going to read a set of calipers, you have to understand how they work. All right, so here's our set of calipers. This is an analog set. So now let's go over how to measure. Okay, so we're going to take this piece of pipe right here, and we're going to measure the ID in the pipe. So when you're using a set of calipers, this is what you want to do. Okay, so I'm using my top set of jaws because those are for measuring ID. So I slide those jaws in there and I kind of wiggle them around. Okay, so there's a set of numbers right here. Those inches are broken down into tenths, and so you can see, hopefully you can see that on the camera. It's 1.6 because the 6 is right there, so it's 1.6, and then you come over to your dial, so it's 1.620. That's your measurement, 1.620. So the ID of our pipe is 1.620. Okay, so now let's do one with the OD. So I'll use the big jaws, right? So I'll come out here, and then I like to kind of twist it and rock it back and forth so I'm sure my measurement's right. Okay, so if you look there, you're 1.6, and then you come over to your dial, so 1.624. 1.624. So your 1.6 and then your 24 on your dial. Alright, so hopefully that gave you guys some insight on what you would use calipers for, why they're important to have in a fab shop, and I use them all the time. A lot of people have a misconception that they're for machinists. They're not just for machinists. They're a really good tool to have even if you don't do machining, because you're able to get a really specific measurement on things, and they're just good to have around. So hopefully that gives you guys an understanding on how to measure with an analog set. So that pretty much wraps up our super cool tool segment on dial calipers. Check them out, get yourself a set. Let's get back to the project. So we want to be 910 thousandths. So you know this is your foot brake too, right? Yeah. We've only got like 80 thou we could take off. So turn your lathe on. Right here. It's out and down, okay? If you go the other way, it spins backwards. See that? Okay. So now, you want to touch off again, but you want to touch off over here. Okay, so go in and touch off. Sometimes it's easier, instead of grabbing the handle, grab it here, and then you can be really sensitive with it. See what I'm saying? Okay, so you touched off. Okay, 0. Now, you want to go in, this is your gauge. You can either do it there or here. We're going to do it here. It's this, but you want to go up, right? So pop it up. And then when you're feeding towards your chuck, you always want to watch and make sure you don't crash the lathe. Okay, now get ready. Keep your hand right here. And you want to push it down. So when I tell you, push it down. Now. Okay. So that's good. Now bring it back this way. No. This one. You go, no. Go this way. So you kind of got to be sure on which way to go, because if you go the wrong way, it'll crash the lathe, right? You know you're where you need to be here, so now all you got to adjust is 30 there. Okay, so now engage. Okay, now that should turn that off. Good. And you want to be careful, right? You did that good. Because if you go too far, it's going to slam it the other way, and you don't want to do that. So you want to go real gentle, just like that. See what I'm saying? Perfect. Right on the money.
Okay. So then,
0.910, right? 0.910.
okay, so that's good.
So how do you say that?
1.25.
Good. Okay, so we're good there. So now the next thing to do is let's go ahead and a good machinist will always chamfer things and clean them up and make them look pretty. So take that off. I'll put that one in. Okay. So now turn the lathe on. You don't have to go clear on. Okay, so you're going to do this by hand. So go over. You want to chamfer this. You know what chamfer is? Just take the corner off. Yep. So you want to take it in. So you drive it. Okay. Okay. Now drive it in. Slowly. Grab it right here, right? You can be a lot more sensitive if you grab it right there. Okay, keep going. See how you're taking it off? You can go faster than that if you want. There you go. Right. Okay, so another thing you want to do is it's good to try to learn the decimal equivalents for fractional measurements. So 5/8 is what? Do you know? 625. So you get on here and you go 625. 0.625. Okay? So we're 0.625. So now we're going to turn this on. I'll do this part. And I'm going to speed it up because it makes better mark. Which I didn't speed it up. Okay, this is the kind of stuff you want to be really careful doing because you don't want to get your sleeve in there, you don't want to get something caught. So I like to use this as a rest when I'm doing this, and then I keep my arm out of the way. Okay, so I always go like this, and then I put this on here and I'm going to make a mark. Okay, then okay, so we got the center drill in, but we got to slow the lathe down. Okay, so how do you slow it down? How do you find out what gear you're in?
This is what gear you're in.
Well, they're all what gear you're in. You got all kinds of speeds, right? So here's your speeds right here.
And this goes to this one.
So how fast, if you want to slow it down, like let's say JKM, right? So put it in JKM. Okay, you kind of don't be afraid to get, and you gotta rock this too. Okay, so it's a good idea to either push this or take this out because that'll put it in neutral. Okay, so J. Okay. There, now you're in gear. Okay, now test it. Okay, that's nice and slow, that's good. Okay, so now you're going to push your tailstock in until it's close to that. This is your tailstock. Not this. Push the whole thing in like this. You don't want to slam it into it, but you want to get it close. Okay, and then you got cutting oil here. Okay, so once you get it close, this is what locks your tailstock. Okay, so we're going to lock that in. Now you're going to use this to drill. Okay, so I'll run the oil and you drill. Okay. start kind of slow. Okay, we're starting to cut. That's good. Keep going. One of the big parts of machining is feel. You want to feel the machine because it'll tell you if you're getting too rowdy with it. It's going to tell you. So can you tell how you're just going nice and easy? You can feel it cutting. It's cutting nice and smooth. See what I'm saying? Keep going. And the deeper you go with these, you're going to hit a point where it's going to start getting easier because you've hit the flute on the. You've hit the spot where the flute gets bigger. You feel that? You don't want to drive these all the way down. You just want to go, I usually go about half the width of the taper. So about right there. Okay, so back it out. So now pull that down. Probably a good idea to take your lathe out of gear. Just go up. Okay, now pull this back. Get after it. There you go. Okay, so now you got to swap the bit out. So here's your bit. So now you got to take this, loosen that. Other way. There you go. Okay, so the shank on the drill bit, see how it's got those flat spots? You want those to be on there. See that? Okay, now tighten it. Drop that for good luck. That's good. Okay, is it tight? Okay, good. Now the way this works, see if I keep going back, see that? So it's not engaged because of the way this works. There's a groove in here, and the tail of this has to be in that groove. See this? So you got to bring it out a little bit. See how it dropped in? So you want to check that when you're drilling holes, okay? So now you're ready to push that back in. Stop. Okay, good. Now lock it in. Okay, that's good. Now come back over here. Now engage the lathe.
Turn it on.
Okay, so now you're gonna drill this hole. I'll run the cutting fluid. You drill the hole and just start nice and easy. You'll know if your bit needs to be sharpened if you're not getting chips like that, and if it feels like you really got to get after it, it's time to sharpen your bit. If it feels like it's starting to get tight, you might have to clear your chips. So you'll back it out. Okay, now go back in, but wait, you got to be careful of that, remember? And then you want to be careful going back in that you don't slam it into the metal. If you do that too hard, it'll snap the bit off. Okay, did you see that? Did you see it grab? And you could feel it, right? Okay. That's good enough because we only got to do 5/8. So now you got that done, so take it out of gear or turn it off. Okay, you can unlock that, slide it out of the way. Okay, I like to get it out of the way. Okay, so now the next thing you'll do is get this out of the way. So another thing you want to do is it's good to try to learn the decimal equivalents for fractional measurements. So 5/8 is what? Do you know? 625. So you get on here and you go 625. 0.625. Okay? So we're 0.625, so now we're going to turn this on. Okay? This is the kind of stuff you want to be really careful doing, because you don't want to get your sleeve in there, you don't want to get something caught. So I like to use this as a rest when I'm doing this, and then I keep my arm out of the way. Okay? So I always go like this, and then I put this on here and I'm going to make a mark. I'm going to part it off just because they're real easy to snap the bit off. So then what you do is you take the side of your part off tool. See where my mark is? And so I'm going to go right there. And then you want to slow it down when you're doing this. Okay. And then you want to use lots of oil. Okay, so we're going to be, there it is. Okay. Good job. Kid's a natural. Here's Bridger's first machine part. Looks good. He chamfered his corners. The finish looks good. He's cleaned up all the burrs off of it. Looks good. I'd say not bad for a first machine project. Okay, so all that's left to do, drop that in. Ooh yeah, fits nice and snug. That way it'll kind of square itself up. We'll weld that on and he'll be able to hopefully drill the crap out of his weld. Okay, so the first thing we want to do is weld our little plug in here. So I got to grind the zinc off of this. I'm just going to hit it with flat disc after I plug in my grinder. I'm going to have Bridger come hold it. And I'm going to tack it on its side like this. And then I'll make sure it's level and everything centered up. And then I'll put another tack on it. Okay. Centered that up. Nice. You can always check it with a straight edge. It's good. Okay, now just hold it to the side like that. I'm going to put a tack on this side. Okay, you can let go. Now the other thing I want to do here, and it may be overkill, but I want to try it. I'm going to take this over to the lathe, I'm going to put it in the chuck. I'm going to spin it, and I'm going to center this the best I can, just by tapping it with the hammer. And then I'm going to come back over and tack it. I want to try to get it centered the best I can so that when it's going around in the drill, it's not doing this number. So I'm going to take it over there and give it a try. This is going to be tough. That's pretty dang good right there, as far as the fitting goes. The fitting's spinning pretty true. It's getting a lot better. That's pretty dang close. I mean, it's got a little bit of wobble, but it's pretty dang close. I'm calling that good. I just about grabbed that with my bare hand. Okay, so we're not going to move it. We're just going to take it over there, put it in the vise, and tack it. So I've swapped the XMT back over to dual shield. I'm going to put a tack down in there. Just another plug weld. It's just a little added security. So I'm going to tack that and this one will be done. So I'll give it a quick burst of energy in there. That'll finish this one up. That Dual shield sure does a nice job of doing just little plug welds, little tacks. So that's that for that one. So we've got our 3 drill attachments here. They got holes in them. All welded on there. This can mount on here, like so. Then he'll hook the drill on, and then he'll be able to drill that down through all the crud and hopefully pull it out, or at least that's the plan. Once he gets down so far, he'll add a coupling on here, add this to the top of the pipe, keep drilling, and that's hot. So that's our drill attachments. That was a pretty complicated project. We ran into a few issues that I didn't think we were going to run into, but sometimes that's how these go. So hope you guys enjoyed it. Hope you guys learned something. Appreciate you guys for watching. Remember to like, subscribe, and share if you're not already. And see you on the next one. Alright, so I think I've figured out what I need as far as Alright, so I think I figured out a design for we're gonna take, get in here, threader. Come on, come see what we're doing. Come on. What are you doing over there? Do you have some sort of obsession with being far away? Bring it back over here.
Corey's is being too close and mine's being too far.
Yeah, it is. Is it recording?
Yeah.
Then what are you doing?
Sorry, I didn't.
Tell me that's not trippy. The way it's coming out of those holes and right up that bit. I could watch that for days. And then once he gets down so far, he'll add a section of pipe. Put a coupling on here, add a section of pipe. Woo! Put a coupling on here. So